first. It's the last topic. We're going to derive this. I'm not just going to tell you how to do it. We're going to figure out how. So, no peeking ahead. We have to work for it. If I just asked you to find the average of something, if it's a finite number of objects, if I wanted the average on the last test in this class, what would we do? Right, add up all the scores and divide by the total number. So we know how to find an average in that case. What if I wanted to find, like, the average temperature for the day? There's not just a set number of readings. We're not just doing, like, once an hour. If I wanted the average temperature for the entire day, that's an infinite number of values, right? Because we can do the temperature every hour, or every minute, or every second, or anything every half a second if we wanted to. So there are an infinite number of values, so we can't just say I'm going to add them all up and divide by the total in that case. We've talked about some of these things before, when we were trying to find areas under a curve and we first split them up into rectangles to get an approximation. So if we try to do that the same way by breaking it into pieces, we've talked about the change in x is ending minus beginning divided by the number of rectangles you want to do. So if we choose these x's, we could calculate the temperature at each one of those x values and then add up all of those and divide by the total, right? Now, would that be exact? No. If I did it once an hour, that would give me a ballpark. If I did it every minute, I would get closer. If I did it every second, I would get even closer, right? The more we divide it up into, the more pieces, the better our answer would be. So, if I wanted to calculate that, did I skip? Okay. The n, if I wanted to solve for n here, we know change in x is b minus a over n. So if I multiplied over my n, change in x times n equals b minus a. So my number of rectangles is b minus a divided by the change in x. So what we're doing is adding up all of these x's. The first plus the function at the second plus the function at the third x plus all the way, the last one would be the nth x. And I divide that by my number of x's. But I could replace my n with b minus a over the change in x. If I wanted to rewrite that, how do you divide by a fraction? Flip and multiply, right? So if I did that, I could pull out the 1 over b minus a. Then I would have all of my x's added together. Times the change in x if I flipped and multiplied. So what I have is 1 over b minus a times the sum from 1 to n of my f of x times my change in x. And ideally, if I want to get the true answer, I would have to do the limit as n goes to infinity of this. And the limit as n goes to infinity of this sum, that is the definition of what? an integral. So my average value is just 1 over b minus a times the integral from a to b of my f of x dx. So we already know how to integrate. That's nothing new. The only difference is you are going to have a 1 over b minus a in front. You're basically going to divide by the length of your interval. So that is the average value formula. It's in the box on the next slide, but we calculated it already. Notation, you might see this F, and then it's got subscript AVE for average. So just know that you might see that notation. I may say give the average value. I might say find F sub AVE, and you have to know what that means. So let's do a problem. I want the average value of the function f of x equals 1 plus x squared on the interval -1 to 2. So my average value, 1 over b minus a times the integral from a to b of f of x dx. So that gives me a 1/3 times antiderivative of 1, x, antiderivative of x squared from -1 to 2. Okay. If I plug in a 2, I get 2 plus 2 cubed is 8 times 1/3 would be 8/3. Minus, if I put in -1, -1 cubed would be a -1 times 1/3, -1/3. Okay, so 2 plus 1 is 3, 8/3 and 1/3 is 9/3, which is 3. 3 plus 3 is 6, so 1/3 plus 6 is 2. So my average value is 2 on that interval. So the only difference, integrals like normal, you just have a coefficient in front, 1 over the b minus a. Let's look at another one. So this is a question for us to think about. Would there be a number, c, where the value of the function is equal to the average value? So is there a number in the interval? You can run the office and grab a box. So is there a number between -1 and 2 that I could plug into my function so that my function would equal my average value, which was 2? We've talked about, remember, it's been a long time, we talked about the mean value theorem and Rolle's theorem, things that we need to know for our final coming up. And mean value theorem said if you had a continuous function, if you took the slope between the endpoints, somewhere the derivative was going to be equal to that. There'd be a tangent line with the same slope. The mean value theorem also applies to our integrals. So as long as we're dealing with integrable functions, functions where we can find the antiderivative, so they're continuous, there is going to be a number between your endpoints that would make your function equal the average value. So let's find that for the example we just did. So I might ask this in words, I might say find C such that f of C equals f of the average. So I could ask it either way. It should be somewhere between -1 and 2, and there could be more than one of them, where f of C, so if I plug in C, that's 1 plus C squared, and f of the average, we just found, what was the average value? In example 1, we got 2. So those things have to be equal. So 1 plus C squared equals 2. So C squared equals 1. Square root plus and minus, so C equals positive and -1. Double check, because you might get a value that doesn't fall within your interval, just like we did mean value theorem. So only include answers in the interval, but -1 and +1 are both in that interval, so we'll keep them both. So this one will be twice. Questions there? I am going to skip example 3. I'm going to go to example 4. Okay, so I want the average value of my function. So how do we find average value? Over b minus a. My a is 0, my b is 2. Times the integral from a to b of f of x, which was x squared dx. So 1/2 times, what's the antiderivative of x squared? So 2 to the third is 8, 0 to the third is 0, so we get 8 over 6, or 4/3 for the average value. Easy enough. Let's do another one together. In Athens, Georgia, the mean daily temperature in degrees Fahrenheit T months after July 15th is closely approximated by this equation. Find the average temperature between September 15th and December 15th. So we have our function, we need our interval. We're measuring months after July 15th. So September would be 2 and December would be 5. So you can count on your fingers. Okay, so we're doing from 2 to 5. So for my average value, what goes in front? 1 over 5 minus 2. And we have to integrate from 2 to 5 of my function, which we were given, 61 plus 18 cosine of pi t over 6 dt. Alright, your favorite, integrated trig function. At least we don't have any identities we have to use today. So that gives me a 1/3. Antiderivative of 61t. Okay, let's deal with this cosine. So my 18 can just stay. Antiderivative of cosine would be sine. When you do the derivative of a trig function, the angle doesn't change, so same is true for the antiderivative. Now let's stop for a second. If we did the derivative of that, sine would turn into a cosine, the angle would stay the same, but then we'd have to do the chain rule. So it'd be times the derivative of the angle. What's the derivative of pi t over 6? Pi over 6. So what do I need in my antiderivative to cancel that? 6 over pi. Is everybody with me there? No. So pi t over 6, if we need to, let's just talk about this part. You could write that as a pi over 6 times t for your angle. Okay? When we do the antiderivative, coefficients stay. So now we deal with this. So what has a derivative of cosine? Sine. In derivatives of trig functions, the angle doesn't change, so same is true with the antiderivative. Okay? So if I did the derivative of this, we get the cosine, we get the pi over 6t, but we'd have to do the chain rule. Derivative of t is just 1 times pi over 6 is pi over 6. So we need to cancel it, so we always put the reciprocal in front, which gives us the 6 over pi. So then if we work through that derivative, we would get the 6 over pi times the pi over 6, and they drop out. Okay. We're integrating from 2 to 5. So this one is not going to be overly pretty. If we wanted, we've got, let's see, 61, let's just write it 61 over 3t plus 1/3 times 18, which gives me 6, times the 6 over pi, so we get 36 over pi sine of pi t over 6. All right. This is one we are going to have to use a calculator to get the exact answer because we aren't going to know all of these. Make sure, what mode should we put our calculator in? If we're looking at our angle, pi over 6, is that degrees or radians? Radian. So make sure you flip it into radian mode before you start plugging in. You're welcome to put it all in at once. You can show as much or as little work here as you want. If I put in my 5, you just get 305 over 3. Okay, if I put in my 2, 2 pi over 6 was reduced to pi over 3. So we're trying to approximate an average temperature. We don't want something in terms of pi. We want a decimal. So let's plug all this in. I got 56.8057 degrees. Double check me and see if you got the same thing. And raise your hand if you're having trouble. So the average is 1 over 4 minus 1 times the integral from 1 to 4 of x to the negative 1/2 dx. So you get 1/3. Add 1 to the power, it's a positive 1/2, so you need the reciprocal in front, which is a 2, from 1 to 4. And you do not need a calculator for this. 2/3, so this is 4 to the 1/2 minus 1 to the 1/2. What's a 1/2 power? Square root. So the square root of 4 minus the square root of 1. What's the square root of 4? 2. square root of 1. So 2/3 times 1 is 2/3. So that's our average value. Now we have to find C. So most of you, when I'm coming around, you had the 2/3. Our C, f of C, if you plug a C into this, I guess I should have said G of C, but you would get C to the negative 1/2. And I want that to equal the average value of 2/3. A negative power puts it on the bottom. A 1/2 just means the square root. So if you cross multiply, you get 3 equals 2 radical C. So the square root of C is 3/2. How do you get rid of a square root? Square. So if I square each side, we get C equals 9/4. That's like 2.25. Is that in the interval that we needed? Yes. So that would be our C value. Okay, I want to talk for a few minutes before you start homework. Tomorrow I would like to do a quiz over the things that we've done in chapter 6, which is the average value, what we did today, the volumes that we've been working on since last week, and areas. Okay, do you guys remember all that stuff? So there'll be probably a couple average value questions, you know, just a finding an average value, probably a finding a C question. Area between curves. If I said something like, you guys probably want ones that actually intersect and have nice values, don't you? Alright. The area between y equals x squared minus 2x and y equals x plus 1. So what do you have to do with these? We have to set them equal to each other. Okay, so I need to know when x squared minus 2x equals x plus 4. So if I subtract over my x, subtract over my 4, we get a negative 1 and a 4. I'm probably going to tell you have to draw pictures on all of these. So sketch doesn't have to be great, but if I put in a negative 1, you get 1 plus 2, which is 3. If I put in a 4, I get 16 minus 8, which is 8. Okay, you could plug in something else in the middle if you kind of need an idea. If you put in 0, you get out 0. If you put in 1, you get 1 minus 2, which is negative 1. If you put in 2, you get 4 minus 4. So 0. Is that enough to kind of tell what this looks like? So there's that first curve. Second one, this is just a line. Y-intercept of 4, slope of 1. So it looks like this. So we are finding this area. Remember, we do areas just by integrating. You have to do from left to right, so from negative 1 to 4. And then what do we put in here? The top minus the bottom. So my top was the line, which was x plus 4, minus the bottom was my parabola, x squared minus 2x. So if we clean that up, we get a negative x squared plus a 3x plus 4. And so then we can integrate. So antiderivative of negative x squared would be negative 1/3 x cubed. Antiderivative of 3x would be 3/2 x squared. Antiderivative of 4 would be the 4x. So if I plug those in, and for the sake of time, I'm not going to keep working this out by hand because I want to make sure we review everything. And we should get a 125/6. Your area should be positive. If you're doing this on the quiz and you get a negative, what does that mean? You flipped it. So you might, if that happens, you had the wrong curve first. Something to keep in mind, if we had a picture with these areas, and let's say it was something like x cubed equals x cubed and x. If you draw that, x cubed looks like this. Y equals x looks like this. So how many intervals are you going to set up? 2, because we have 2 different pieces. Now if you set those things equal, you get 0, 1, and negative 1. So you'll have to integrate from negative 1 to 0 and from 0 to 1. Why do I have to break those up and do them separately? Because there's a different curve on top in each one. So if they intersect multiple times, break them apart so you can do the top minus the bottom for each. You know, for the first one, it would be the x cubed minus x. For the second one, it's going to be x minus x cubed. Are we okay with finding those areas? That was the first section. Then second section was volume, so we'll probably put a couple volume equations. Probably one that we rotate around a horizontal line, so that's when we keep it in terms of x, and one where we rotate around a vertical line, so we do it in terms of y. And we've done a lot of that practice the past few days, and then a couple average value questions. So probably like 6 questions on your list. Okay. You have the rest of class to work on that.